Okay, the next example is talking about the three situations where limits can fail to exist. Now, two of them I agree with. One of them you can make an argument for or against and be correct in either instance. The first case is, and we've already discussed this a little bit, is where the right hand and left hand limits disagree. Okay. Yeah, that looks good. Okay, so here's the deal. We can see this if we're looking for the limit as x approaches -1. Well, coming from the right, it's 1 because it's just a constant, flat, zero slope value this whole time, 1. And coming from the left, it's -1. They don't agree at 1. We've got this step that's happening here. All right, so we can see you would put it does not exist, but what would your justification be? Well, the justification would be that the left hand and right hand do not agree. So we would actually have to say, let me break out my pen. Let's go this color. All right, and then we would actually have to say, okay, the limit as x approaches -1 -1, we'll go from the left first of f of x. This is f of x, yeah, f of x is equal to -1 because it's constantly that amount. If I take those two, absolute value of something and divide it by itself, well, it's going to be either +1 or -1, depending on the values. All right, so that's what we're looking at here. So -1, and then at the same time, the limit, I'm going with it, as x approaches -1 from the right of f of x is equal to +1. All right, so that's the one up here. So coming from the right, it's 1. Coming from the left, it's -1, and then it has this jump in between. So since those two do not agree, the limit doesn't exist. All right, so therefore, the limit as x approaches -1, in general, slow down, does not exist. Because the limit as x approaches -1 from the left of f of x does not equal the limit as x approaches -1 from the right. I'm just going with it. Boom. Okay, and you're like, man, that's kind of wordy. Yeah. The more you say, the better on this stuff. The more you say. All right, let's look at the next one. All right, the next one I actually broke out the calculator for. All right, it's as you approach 0 for a sine of 1 over x, and it's this crazy looking thing right here. All right, this is called oscillating behavior. Okay, so I think I spelled that right. Miracle. Okay, so, but how do you talk about it? I mean, like, okay, because like when you look at the graph, all right, like if I graph this, let me get this out of the way. All right, if I graph this thing, and I just did a normal zoom 6. Kind of messes with my calculator a little bit. I can't really tell what's going on. All right, so, but what if I tried to zoom? All right, so I'm just going to zoom in right there at 0, 0. Okay, a little bit better. Let's try one more time. Zoom in right there. Okay, now we're getting a feel for it. it's just kind of like it's zigzagging back and forth between these things. But you're like, well, how do I know whether it's approaching anything or not? Well, what I did was then I was like, well, that didn't really prove anything to me. So I was like, I'll go look at the table. All right. So I went to table setup. All right. And then let's just have it start at 0. Let's just clear that out. Start at 0. And then let's just try a couple of values here. Let's go. We're going to move by 100ths. And then I went auto all the way down. All right. And so let's go to the table and see what we can see. All right. Okay. Okay. Got an error at 0, of course, because it's a sine of 1 over 0, and nobody knows what that is. But then as I got coming from the left, I guess it was heading towards that, and from the right, the exact opposite. I don't know. Yeah, so let's try to move that up a little bit. Okay, so let's get even closer. All right, so 0, 0, 1. All right, and then let's have the table start at 0. All right, and so let's go to the table and look, and I got the same kind of situation. It's definitely not approaching anything because this is a negative. The opposite of that, it appears in every one of these situations. So coming from the left and from the right, they're definitely not heading towards the same thing. Well, it turns out that they just keep going back and forth, back and forth, back and forth. The closer you get, it kind of reminds me of a crystal. Like you zoom in, you see the structure. You zoom in again, keep seeing the same structure as you zoom and zoom and zoom. I mean, I could try it one more time just because I want to, but you don't have to. All right. On these, if you see this oscillating kind of behavior, you would say it does not exist. Okay. So let's try it. Let's try again. Oh, no. Oh, sorry about that. Let's start at 0. Okay, good. And then go to the table. Just all kinds of stuff. But again, I'm seeing the opposite situation on these because of the nature of sine. But the important thing is it's not approaching anything. Okay. So the justification, I don't really know what to say. I mean, look at a table or the graph. I don't know. I don't know what else to say because the limit doesn't appear to approach any value. I guess. Okay. All right. Now, okay. So I think I don't need the calculator anymore for number 3. But now here's where you could make an argument. Okay. Down here, we have this volcano-looking thing, and as I approach 2, it looks like they're both heading to infinity. All right. So I think you could say infinity. However, sometimes they'll say it doesn't exist. Now, they're going to see one in your homework where it definitely doesn't because one side's going to go up and the other side's going to go down. It kind of reminds me of video games, like you walk through the floor and you come out on the ceiling. One of those deals. That one definitely doesn't exist because you could say this side was infinity and this side was negative infinity, and those don't agree. All right, these do agree because they're both heading towards infinity. So it almost seems like you could almost say that the limit is infinity. All right, and be justified. Okay, so it's an argument, and then you just have to see. Like if it's a multiple choice, I think if you went one way or the other, like on a free response, they would count it right. Oh, by the way, this is unbounded behavior. Behavior, but I'm going to put a little question mark there because I think you could say, I really honestly believe that you could say that this answer is infinity. All right, so the limit as x approaches, both of them, I'll do the left first, 2 from the left of f of x is infinity. All right, and then the limit, slow down, as x approaches, there we go, 2 from the right of f of x is also infinity. Anytime I try to go too fast, it's just it goes crazy. So what do you want to say? you know, you. I mean, I think you could say. I think you could say on that it is infinity. But if the answer choice, of course, was does not exist, and then there you go. All right, and you're like, well, I don't like that. No, I don't either, because but I do believe you could say infinity or does not exist. All right, so let's put that. So you could put infinity or and be justified either way.